Okay, today we are working on CO1. I can identify whole numbers, integers, and rational numbers. With a number system as big as ours, it's helpful to have it broken down into smaller categories. Here are a few of them with the most specific category listed first. So the whole number is a positive number. But it's not just any positive number. It cannot be a decimal or fraction. So not decimal or fraction. Then we have integers. The integer is a positive or negative number. Remember, we're going to get a little bit broader as we go down. Positive or negative number. But still not a decimal or fraction. So it just opened up a little bit more to include those negative numbers. Then we move down to the rational number. Now, the rational number really opens up. So we have positive or negative number. It can be a fraction. Or a decimal. That ends or repeats. So the decimal has to either end or repeat. So if it is a decimal that keeps going on and on and on, it would not be a rational number. It has to have an ending point, or it has to be a repeating decimal. An irrational number is the fourth category. It does not fit into any of those three categories above, so it's irrational. It is a decimal that does not end or repeat. So if it's irrational, it means it has a decimal that goes on and on and on forever. Never ends. It doesn't repeat itself. So here's a way that you can visualize how the four categories are related. Are there people still reading? Should I leave that, or can I scroll up? You're still reading? Okay. All right. So I'm going to scroll this up so we can see.
Yeah, put the grid.
All right. So here are some ways you can visualize the four categories. We have rational number. Well, let's start with the whole number, the smallest category. So that could be a 5, 9, 13. Let's think about our basic numbers that we think of. An integer can be negative. So we could have -8, -20, -12. Those are examples of integers. Integers can be positive or negative. Notice how they're not fractions or decimals. The rational numbers, we can have those fractions. We can have a repeating decimal. We can have just a decimal that ends. It can be negative fractions. So those rational numbers can have the fractions and decimals as long as the decimal ends or repeats, positive or negative. So we start with just the positive whole numbers. Integers are positive or negative. Rational, you can throw in the fractions and decimals, positive or negative. So it gets bigger and bigger and bigger categories. Irrational numbers are something like pi. We a lot of times say pi is 3.14, but really pi goes on and on and on and on. It never ends. Square root of 12 goes on and on and on and on. It never ends. A decimal point with lots of numbers after it. And you see that dot, dot, dot that will come? That means it goes on and on and on. It means it does not end. So if you see the dot, dot, dot after the decimals, it goes on and on and on. So another way to think about it, let's say you're a 6th grader, so that's a whole number, who is a part of the middle school, that's integers. So you're the one thing, part of the bigger middle school, that is a part of St. Vincent de Paul School, which is really big. So that would be the rational numbers. And then there are students who attend a different school altogether. My kids go to Blaine High School. That would be irrational. All those kids going to all the other schools. So you see how it's small, gets bigger, bigger, bigger with our categories, and then irrational. So look at where this little exclamation point is. It says simplify a number before making a final determination about its category. A number like 42/7. We have 42/7. That may seem like it is only rational because it's a fraction, but can we simplify that fraction? Yeah. 42 divided by 7. So that's actually a 6. So that's actually just a whole number. Okay, so you can narrow it down. So I should rephrase that. Is it just a whole number?
No.
No, it starts out at the top. It is a rational number. It's also an integer, and it's a whole number. So it's all three of them. If it's just a whole number, if it's just a rational number, then it's going to be, let's see if I can pause this.
On the top by the.
They'll call back. All right. Well, I didn't get to it.
It's right above like the arrow.
It was right here. Oh no.
Good it's by like the puzzle piece. It's by the puzzle piece on top. Like that's how you pause it.
I'm sorry. So tell me where I pause it.
Right by the puzzle piece on the top. Like if you click on like the arrow. No, the arrow. The arrow with the red dot right next to the left. Yeah.
Good times. Okay.
Yeah.
Okay. So remember, if it starts over at the top, it's just that rational number. So picture it like this. It can be rational, but if it's really big like this, it's not going to fit down the filter unless it's an integer. And then our whole number. So the rational is really big. If you can narrow it down, like going from 42/7 to 6, so that's going from that integer down to that whole number. It's all three of these. So that 6 is there. The 42/7 would be here. So if it is a 1/4 up here, 1/4 isn't going to be able to narrow it down. So 1/4 would just be a rational number. But that 42/7, that's actually a 6, is a rational number. It's an integer and it's a whole number. It's slid all the way down, so it's all three of them. Let's look at
Bing bong bing, bing bong bing. Man, he's having a great